of 4 meter dia and height is 3 meters. M for the concrete, you can calculate E. Okay, then you can calculate MI. And HI is tau. Okay. Then calculate period for circular water tank. In the code, direct formula is here. MI you can read from graph or you can use formula, whatever. For TI, CI, H square rho, AYD. Okay. All right up to this point. Then you can calculate AHI. Now, pressure above the base will be due to what? So, you have to consider the hydrostatic component as well as hydrodynamic. Hydrostatic component will be simply linear, where this is rho GH, that is the hydrostatic pressure. Then the hydrodynamic pressure, actually on the base also it will be same, rho GH, and the dynamic component will also be same as this. Okay, so let me call this PIB max. Okay, this will be same as PIW max. Sorry, PIW max. What is acting on the wall? Maximum value of that you calculate, or maximum value of the pressure acting on the base. You calculate, both should be same. So either of the two formula you can use. So go to this page number 9 for circular water tank. Okay, PIW, maximum value of PIW will be when cos phi is 0, sorry, cos phi is 1, phi is 0. So when phi is 0, AHI we have already calculated, and y at the base. So when you put y equal to 0 and phi equal to 0, you will calculate. So this will be 0.866 tan hyperbolic 0.866 d over h. Alternatively, you can use the formula PID. When that will be maximum? Again, when phi is equal to 0, when phi is equal to 0, x will be equal to d by 2 and ls will be equal to d. So you will see that that formula also becomes the same. Both formula will give you the same. So this is hydrodynamic pressure. You add into it hydrostatic pressure. That will give you the maximum pressure at the top of the base. Okay. Now at the bottom of the base slab, so the horizontal pressure which is acting here, this is equal to AHI into G. That will be your horizontal pressure. It will be acting at a height of HI star, and the vertical force will be equal to the weight of water. So that will be pi by 4 d square, okay, into gamma w into h. That is the weight, and then vertical load P is equal to W, and the moment M is equal to AHI MIG into HI star. And then you can calculate the maximum pressure at the base is equal to Pi not I, let me call it P overturning. P overturning at base is equal to P by A plus M by Z. So that is equal to P divided by pi by 4 d square plus M divided by pi d4 by 64 into D. That will give the maximum pressure at the base. Okay.
Sir, this
Yes.
movement you are taking is about which axis?
Moment we are taking about the center. Let me go here. About this axis. Moment about this axis. About the base.
You are
About the center of the base.
you have asked for the this pressure at the top and bottom of that slab, and that slab is looking like this, point 3. Thickness. This pressure will act like this, and from this
अरे
direction.
कोड को बर्बाद कर दिया हो ना.
तो यहाँ पे ये मूवमेंट है सर.
हाँ.
तो ये तो प्रेशर हो गया. इसकी वजह से यहाँ पे ऊपर कंप्रेशन आ जाएगा, नीचे टेंशन आ जाएगा इस साइड.
इसकी वजह से मोमेंट की वजह
ओवर टर्निंग मूवमेंट की वजह से. देन
से. वही m by z है.
हाँ.
Then that m by z for maximum it will be plus, for minimum it will be minus.
But that pressure is in vertical direction, and that
Yes, it is in vertical direction.
and due to that movement, the generating that pressure is along horizontal. So
No. Moment does not cause horizontal pressure. Overturning moment also causes vertical pressure. When there is an overturning, this side it will be compressive upward, this it will be tensile downward.
Due to
This
that-
is also vertical.
Yes.
So that P by A is also causing vertical pressure, M by Z is also causing vertical pressure. So it will be added.
that P by is okay. That due to overturning movement, one side is going in compression, one side is going in tension. Due to that, on both top and bottom, same effect it is induced.
I couldn't get at the top and bottom how same effect will induce.
Because
This so what is happening here? Suppose earthquake force is acting in this direction. So there will be a pressure acting like this. There will be pressure acting like this. There will be a pressure acting like this. Okay. And then this total moment of all this you have to consider. That will act from the base. So at the base, it will be acting like this. Whereas at the top it is only this. So moment at the base, the pressure at the base will include effect of this wall pressure, as well as effect of the pressure acting at the top of the slab. All that together. because this will be transferred through this wall. This pressure will be transferred to this wall. So this wall will bend. This wall will also bend. And it will transfer that moment to the slab. So on the slab, the total overturning moment will be more than what is coming from the top. So pressure at the top will be less. Pressure at the bottom will be more.
Consider this as a rectangle and it's not circular. In circular rectangle there is water, and due to the weight of the water divided by this plane area is the pressure creating at this. Then we are considering volume speed and it is acting like a wheel. Now
what you are missing here is the pressure coming on the wall.
Pressure.
Show the pressure coming on the wall also.
Due to that pressure coming on the wall,
What will happen to the base slab? Suppose there is no pressure at the base. Suppose there are only walls. So on the wall there is a pressure.
Yes.
Will there be any pressure at the bottom? Vertical pressure or not? If there is only wall pressure, no vertical pressure at the top of the slab, will there be any pressure here or not? Will be. That's what you are missing. Because of this it will try to overturn. So there will be a resultant force acting here. Due to that there will be an overturning moment, and due to that there will be pressure. Compression this side, tension this side. That part you have missed. When you are considering HI star, that's the difference between HI and HI star. HI star includes the total pressure. HI includes the pressure only on the wall, and HI star includes the overturning moment due to pressure on the wall as well as on the slab. So when you have multiplied this by HI star, the all effects of the pressure at wall as well as at base have been taken. Okay. Then same time, now I have put at the top of a column 1 meter diagonal. So again you should calculate MI and HI star. So we are considering at HI star, not HI, because we are considering overturning moment here. So I know this HI star, you can replace this by a single degree freedom system where this is MI and this is five meter plus HI star. You can calculate I. 5 by 64 into D4. E again you can calculate EI and then you can calculate K, that is equal to 3 EI by L. Okay, then you can calculate omega, you can calculate T. So once this TI is there, you can calculate AHI. Okay? AHI is known, then you can calculate VI. So VI will be AHI into 5 by 4 square into 3 into gamma W. Okay. Similarly, you can calculate MI VI into 5 plus HI star. Then you have to calculate the resultant, because vertical component of the earthquake, will it cause any horizontal force? No. So vertical component will not have any component, but 2 horizontal components need to be considered. So VI will be the square root of VI square in one direction plus 0.3 VI in the other direction. Similarly, MR will be the square root of MI in one direction plus 0.3 MA.
For calculation of that stiffness, the stiffness is Ks, stiffness of the stacking, like 0.1. So we can learn that overall mass of the water tank at a unmeter only and then
Because MI act at this height, MI does not act.
but we need stiffness of that stacking, Ks.
Whatever you do, the force is acting here. So the stiffness will also be calculated here, where the mass is acting. HI star. Because this is due to overturning. Okay. So whatever force is acting on the wall, that will also be acting, and this will also be acting. All this will create moment. Okay.
So this case of stacking, this case stiffness is also stacking. Right?
It is of the tank, water tank, which includes staging.
And sir, in this formula, this E comes up to 1000 kPa in Newton per mm square. But all the parameters are in meter, this is in meter, then this is ratio, this is also in meter. This we have to change in Newton per meter, like this, because it put to that time value
And it is coming high.
9.165.
Should not.
Because it is
What is the value of CI?
CI is 4.3. 4.3 comes to 1.7. H is in meters, this is critical meter.
D by D is dimension.
But here I will let's say Newton per meter square.
You are converting this into Newton per meter square. Until unless it is written that the dimension is in millimeter per millimeter square, you have to convert this. So that's why your value is coming out to be higher. You have converted this into meter square.
It is a empirical formula.
This is empirical formula, but in empirical formula also the units are important. In fact, empirical formula units are more important. In case of consistent formula, you can keep units consistent and you will get the same answer. But in case of empirical formula, units are very important. If you change the units, okay, so fine, we will evaluate that and display all the rest for the result.